Hey everyone, it's me, Steve. It is March 4th, 2019, and as you can see, that's a Fahrenheit. There's a time, it's in the morning. But anyway, I thought we were done with this bitter cold. Apparently we aren't. So anyway, what is today? Today is Geo-Rant number 93. And briefly, first I'm going to talk about, remember in my igneous identification of a rock, I mentioned this book and I just had the proof. Well, it's out now. And this book, unlike this book, which is meant for field use and is totally in black and white, this one is not. This one is thinner, it's bigger. As you can see, this one's, like I said, this one's 6x9 as opposed to this one. Okay, and the sedimentary one I'm working on right now, that'll have a green cover, and then metamorphic, I haven't even begun, it'll have a blue cover. They'll all be this size. And this does have all the pictures of any rocks, any photos in here are actually mine. We have some color charts in here too, of actual relative color charts, one with scales, explaining some basic concepts that you see. Here's bones. This is in black and white, even it's not in color because I originally wasn't going to do this book in color, but I figured it wasn't going to be too long and I could do it in color. Feldspar phase diagrams, you know, other pictures. I just wish this would have printed better. That's a sodalite. Let's see what else I want to show you in here before I get on with the actually today's Geo-Rant's actually going to be about what is a mineral. And I'm just showing you this because, you know, there's minerals in here and you use them to identify igneous rocks. You use the minerals. Well, what is a mineral? Basically, a mineral, wait, before I get into that, what's a rock? All right, and this is a little complex story here, but basically a rock is an aggregate of one or more minerals. You can have a rock made of one mineral, like a quartz arenite sandstone, like the St. Peter. That's like 98% mature. It's essentially quartz. All right, so you can have rocks made of one single mineral. Most aren't. Most have a couple in them. But not all rocks are made of minerals. Like coal is not a mineral, but coal is considered a rock. Why? Well, because we've been naming and digging out coal since before we had standards on this kind of stuff. Before we even really knew that we had 6 systems of minerals, 6 crystal systems, and how to identify them and all this stuff. Before that, we were already looking at coal in the ground, and it's bound by rocks, usually in what was used to be called a cyclothem, which is no longer a legitimate stratigraphic unit. But you know, you'll have clay below or something, and sandstone or limestone or something like that. So those are all rocks, so the coal must be a rock. So there are exceptions to what is a rock, but in geology, a mineral is inorganic by definition. Okay, so a mineral has to be several things. It's inorganic. It is a solid. Okay, magma is not a mineral. I've said this before. It's a concoction of chemicals. All right, because it has to be solid. Because the only way it's going to fit the next part is if it is solid. It has to have the potential to form crystals bound by planar surfaces. Okay, so it forms crystals. Now, come on, Steve. All right, this is a natural forming quartz crystal. I've showed this to you before. It's hexagonal. We have the 6 sides that define being hexagonal. This has calcite on it. These are rhombohedral looking crystals, but they are actually hexagonal as well. This is a geode from Indiana. This is a quartz crystal from Arkansas. And yeah, there's going to be some show and tell. And my neighbors, when they went to Arkansas, I believe it was last month, maybe in January, they got us some quartz crystals out of the ground. See? So, I mean, some of these are broken. Like this is a mineral doesn't have to form crystals to be considered a mineral. There's something called a mineraloid, but that's not a mineral. Mineraloids like opal never form crystals. It's just their lattice structure is just molecules jumbled together. They don't form ordered, organized crystals. And the reason why quartz forms these hexagonal crystals all the time is because it's part of the way that the molecules of SiO2 are arranged. That's what forms these crystals. So, well, Steve, why are you doing this? Why are you telling us all this? Because somebody online tried telling me water ice is not a mineral. And they tried to tell me it's a mineraloid. It is not. Part of the definition of a mineral is it has the potential to form crystals. We have something called microcrystalline. If you look at it under high magnification, you'll see the crystals. Ice is a crystal. It forms hexagonal crystals. That's why snowflakes have 6 sides. Okay? So it can potentially, you stick it in your freezer, you're not going to see it, but it's still a mineral because it has the potential to form minerals. And I'm going to do a demonstration, hopefully making large ice crystals instantly like that. I will link to a video below, a BBC one that shows how this is done. So ice can form crystals directly from water. In this case, water would be the magma. Okay? So ice is a mineral. All right? It does form crystals. It can form crystals. It's inorganic. It fits every part of the definition of being a mineral, and it's even included in some mineral books. It's just it has a high melting point. Usually when we think of minerals, quartz deep underground will start to solidify at about 600 to 700 degrees centigrade. So it's pretty hot. Ice is at 0 degrees centigrade before it becomes a solid. Now, this is only water ice. This is only the ice we're familiar with in everyday stuff. It's not like the ice in deep oceans like what you would expect under Europa. I forget, the Ice 7 or something like that. I could be wrong on that. This doesn't include those. This is just like stuff that forms glaciers, stuff that's covering Antarctica, Greenland. That's what I'm talking about when I say, ice. And like I said, if it has the potential to form crystals, it's still a mineral. Because quartz itself, like that mineral quartz, in my rock identification minerals, part 1 and 2, which if I remember, I will link below as well. The quartz in that, which is pretty common in igneous rocks, it's what we call granular or globular, or if it's big enough, we just call it, and it's sitting by itself, we'll call it a bull quartz. There is no discernible crystal structure in that, because what happened is the quartz cooled really quickly. And remember Bones reaction series, quartz is the last thing to cool out of an igneous rock. So as the rock cools, it's going to lose that remaining heat faster and faster. So quartz generally does not form really good crystals in igneous rocks. It can, but it doesn't usually. So you get what's called microcrystalline. If I could look at it under electron microscope, I would see individual crystals. Okay, but even under powerful magnification, even with my 40x hand lens, I'm not going to see the individual crystals. Okay, so, but it's still quartz. It's still a mineral. All right. So anyway, I think that's pretty much it before this gets too long. It's already over 8 minutes. But if you have any questions or comments below, please leave them. All right. Thanks.